So what we did in the last couple of years, working with Kim in the partnership, is we started putting Paul Hymo into the water balance model because we needed a tool that addressed some of the engineering issues in a clear and scientific method. So what I'm just going to do is quickly, I'm just going to step through this, and at any time, just stop me and we'll have a chat. The thing that Paul Hymo does, it has it estimates both the surface runoff and the groundwater return to the stream. So it has the groundwater built in. So when we start looking at the mass balance in the stream and then the discharge, it includes both the surface runoff and the groundwater. What people typically see in single event design storm models is runoff, surface runoff, period. So it takes a bit for the initial users to actually understand that it's not just the peak flows, we're also dragging along the base flows that are discharging from ground as well. And that has to be considered. It's a fundamental shift in thinking when you're dealing with modeling. And a couple of things we can do with the model that are really fundamental is we can look at surface effect, how the surfaces affect runoff, how it interacts with the rainfall, how it captures the rainfall. The next thing we can look at is runoff reduction, because it's the runoff we want to reduce, not the total discharge. And that's really the volume of surface runoff. So that's fundamental in the process that we built into the water balance net model using Paul Hymo. The surface effects are really we're looking at what can you do to the surface, what are the impacts, and what are the mitigation that you can do. The impacts are increased imperviousness, say, decreasing concentration. What mitigation can you apply to the surface? Adding vegetation, decreasing imperviousness. You need to decide how you do that, but we can model it. So absorbent landscapes could be vegetation density, increased topsoil depth. Porous pavement is a change to the surface. Green roofs are typically a change to the surface. Some infiltration swales are as well. And that's as far as the old water balance model went. And now what we've added, we've all added capability of looking at runoff reduction. And that's the stuff that what happens to the runoff, is the surface runoff. And when we start talking about the infiltration galleries, we need to store it, we need to capture it, we need to store it, and let it infiltrate. So the things that we do to that, that we have in the model that will allow you to look at things like that are rain gardens with storage, infiltration swales with storage, surface or subsurface storage, infiltration ponds, and underground galleries. So these things are built into the model. How to start? This is when you go back to the planning process. We have to define what the problem is, and because defining the problem also helps you determine what are your possible solutions. Right? And using the water balance model is just a tool in the process, and it allows you to look at what gives you the biggest bang for your buck. And because it's set up for most users to use quickly, you can get some numbers on it fairly quickly, and you can throw out the things that just won't work very well or cost too much. You can do that without even a lot of consideration. And it allows you to interact with the planners, the engineering. It allows you to interact with the parks people. And it allows you to quickly, in that process, create a vision for your watershed. Like, what do you want it to look like? And it allows you to establish what your targets are and what you have to do with that vision to reach your target. Again, it's just a tool. It's part of the process. So what does the tool look like? Well, when you log onto the site, this is the home page, and it tells you Uh, it gives you just a brief start. So it's waterbalance.ca. On the right, it shows you the kind of projects you can look at, site developments, watersheds. If you scroll down, you can get some of the story behind the water balance model, wall panel. There's a lot of information available there to download or read. On the left, this indicates that it's a Canada-wide site. So you click on the province that you want to work in. And typically, you'll be working in BC, so you click on BC to go. But Alberta is also part of the partnership, and they have their own site. You just click on it. Click on BC. The next the next page that comes up gives you information that's BC specific, and it allows you to launch the water balance model. So if you launch it, you get the login site. So far, it's pretty simple to use. You need a password login ID. Once you're into it, it starts asking for information. Well, and you just have to fill in the boxes. Things that you would always have with your sites, like drainage path, length, elevations. If you know anything about your site, you have that information. If you don't have that information, well, assume something. Plug it in, see what it does. Enhancements. Here are the suite of surface enhancement that you can select. Absorbent landscaping, pervious paving, filtration swales. A number of things that you can do to enhance the surface. You can have the same surface controls that if you had a storage component and you're starting to react to the runoff. And this is so the runoff is routed to these. Okay. Once you've done all that, you can hit save and check results. A couple of screenshots of what the results might look like. This is just one example. Here we built in the flow exceedance charts, and it shows you that you can compare different scenarios. So if you have a project, you typically set up your pre-development as your base case, and then you would assess a number of alternatives, different approaches to your project, to see how close to the pre-development level can you get. That's one part of the answer. Mass balance is another part of the answer. It gives you a comparison between your alternative scenarios. And it does this all on one sheet. And if you're looking at a stream, it also will provide you with an assessment of the erosion potential, the change in the erosion potential. And in this case, the base case is always set to 0, and then the change is measured from that 0 base. So it is possible to get a negative number, but you'd have to have your special development to do that. So it's all set up to give you these answers very quickly in a manner that is consistent and will give you the results in a consistent presentation manner, so you can see it. So when we start looking at back to the process and acknowledge that the water balance model is just a tool in the process, what's important in the process? I think the watershed vision is very important. Establishing what the targets are is very important, because when you do that, it allows you the opportunity to start integrating things like planning, your engineering, your environment, education opportunities. And I'm sure I don't have the full list here, because you can go on and on. And what we can take away from this is that through all this process, we're learning and we're adapting, we're changing. And this is the next step in this whole evolution of land development, how we treat the land and the neighborhoods and the